Alright, so we're going to solve inequalities today. I want to begin by solving an equation. So negative 3x minus 7 equals 8. That seems like a good equation to start off with. And if I start off this equation, if I'm trying to solve this equation, my first step is to move the 7 to the other side. It becomes positive 7. Negative 3x is equal to positive 15. The next step is to divide both sides by negative 3. And that gets me x is equal to negative 5. Alright, that's solving an equation. Now, after you've solved that equation, that's it, that's the answer. Alright, solving an inequality has the same technique, but there's one extra thing to consider when you're doing the division step. So, let me put the same problem here, negative 3x minus 7 and 8, but instead of saying equals, let's say greater than. Alright? So, if I'm trying to solve this, my first step is to move the 7 to the other side, just like it was over there. Keeps me negative 3x on this side, makes it 15 on this side. And when I'm doing this type of stuff, just sliding something across the equal sign, changing the sign, or the inequality sign, nothing happens to the inequality symbol. In the division step, though, when I divide by my negative 3 here, divide by negative 3 here, this makes x, this makes negative 5. This becomes less than instead of greater than. Okay, so if you divide by a negative number, you flip the inequality around. And when people see it done in an equation setting like this, a lot of people get like mystified by like, well, that's just like some crazy thing you got to do with inequalities. So then they start thinking maybe I'm supposed to do that every time I do an inequality. So if I, for example, get this problem here, suppose I get 2x plus 9 is greater than or equal to 7. Right? And I move the 9 to the other side, makes minus 9. That gets me 2x is greater than or equal to negative 2. Again, doing this step, nothing happens in inequality. And then here I divide by my 2. I'm going to get x is greater than or equal to negative 1. So now it starts looking like math is all weird and stuff, because sometimes we do things, other times we don't, and there seems to be no rhyme or reason to it, because there's negative in this one also, and the answer is still negative, right? All right. What makes my decision whether or not I flip that inequality around is what I'm dividing by. So this right here makes the decision for me.
Well, if it's a negative.
If I'm dividing both sides by a negative, I'm changing signs. Changing signs creates a flip in the inequality. With variables, it's understandable that people don't necessarily know that. When you deal with real numbers in inequality world, then it's a lot easier to see this. Suppose I start off with something that obviously is true. 9 is greater than negative 2. Can we all agree that's true, right?
Yeah,
9
sure.
bigger than negative 2. If you have a bank account with $9 and somebody else has a bank account with negative $2, you have more money than that person, right?
Yeah.
Not a lot more, but yeah. All right. You're in better shape. All right. If I change the signs, which is what dividing by a negative does, changes signs, right? If I change the signs, this 9 becomes negative, this 2 becomes positive. Which number is bigger?
The 2 now.
The 2. By changing signs, the direction of the inequality switches. That's why we're going to flip that inequality around when we divide by a negative. If there were an equal to on this, and there's still an equal to on there, so there's still an equal to on it. Equals doesn't change. If it's equals, it's equals. If it's not, it's not. The direction of the inequality switches. That's all that switches. So, if we look at example 1, graph the solution. To solve an inequality, we want to get x by itself with no sign or number in front of it. So the fact there's a minus in front of this x means I have to make that a positive x. To change this sign, I have to change that sign. And if I'm changing signs in an inequality, the direction switches. Equals stays equals. So that's what solving an inequality means. X all by itself, inequality symbol followed by number. And then I'm supposed to graph this solution, this is the solution here, on the set of real numbers. Okay, I'm always graphing on the real number line, right? If I ask you guys what this is called, you say a number line, right? But its actual name is the real number line, if you want to give it the full name called. Real number line, clean your room, all right, whatever. But this is the real number line. So if I'm graphing on the real number line, it just means graph like normal. So, negative 4, negative 3, negative 2, negative 1, 0. Just put some numbers on there. Make sure this number is on there and somewhere towards the middle. X is less than or equal to negative 2 gets me a closed filled-in circle at negative 2. And less than goes to the left, so I would shade that off to the left, making my arrow bold like so. Anytime you're graphing reals, your graph should look something along those lines. a open or closed circle, either going to the left or going to the right, with the arrow shaded in.